given the following acids and the Ka values, which is the order of increasing base strength? And I emphasize base because that's not acid. We're looking for the order of base strength, okay? So, now, with that being said, they're giving us HClO4, HOAC, HCN, and HF, and these ones had 3.53 times 10 to the negative 4, 4.93 times 10 to the negative 10, 1.76 times 10 to the negative 5, and 1 times 10 to the 7. Wow, okay, definitely blows them all out the water. So, let's first ignore the question briefly and just understand what the Ka values mean, okay? So for this, a higher Ka value means a stronger acid, okay? So, if we wanted to label this by strongest to weakest acid, we have the biggest number of the Ka will be here, then it will be the HF, then HOAC, and HCN. We've now gone through and labeled these all by the acid strength, okay? So HCl4 being the strongest acid. But now, if we're going by base strength, if you're a strong acid, you're either not a base or a very weak base. So you'd be like the lowest base strength, okay? So with that being said, if we were to organize this now by the strongest base, it would be the lowest acid. So it would be 1, 2, 3, 4. Because HCl4 is such a strong acid, it would be the weakest base. But now they're asking for us, now we look at the question finally, increasing base strength. So we want to start from the weakest to the strongest, okay? So if we list it out, we would go 4, 3, 2, 1. So it would be HClO4 would be the lowest, then it increases to HF, then it increases to HOAC, then finally the last one is HCN. This should be the order we're looking for based on our order and based on what the Ka values mean. So that being said, let's see what we're dealing with, okay? So as you notice right away when you look at the answers, they don't have the protons anymore, the hydrogens, which is actually the more accurate choice because of the fact that we're looking for the increasing base strength, you're looking at the conjugate base. So right under here, I'll actually write down what the conjugate base for each one would be. That'll be without the protons. So ClO4 minus, OAC minus, CN minus, and F minus. Okay, that would be it. So with that being said, we would actually have OAC and that. This would be all our conjugate bases in the order. So with that being said, we have ClO4, F, OAC, and CN. And the only answer that matches that completely would be C. C would be the order of increasing base strength because at the end, cyanide is the strongest one and the weakest base, in fact, probably not even act as a base at all, would be ClO4 minus. Because of, as a side note, when you see a Ka value that's greater than 1, as that 1 times 10 to the 7, that means that it literally dissociates completely. It wants nothing to do with that proton. So, in fact, if you put ClO4 in a heavily acidic environment, it won't take any hydrogens to itself. It will literally just sit there as ClO4 minus. Cyanide, on the other hand, throw it into an acidic environment, and you will definitely see some HCNs floating about. That's what would happen there. So exactly. So weakest base, and it will increase there to the strongest base right here. Okay, and that is what our answer is going to be, C. So ClO4, F minus, OAC, and CN, because when you order it, it's going to be the strongest acid to the weakest acid, which is what they did. And if you're the strongest acid, that means you're going to be the weakest base, or even not a base at all. So let's go on now to question number 12.